Welcome to DRAM Innovation blog. Today I am going to demonstrate one machine here which is I have developed by couple of days here in my room. You can see here one machine in front of you. This machine actually is a coffee router which is I developed by some general scrap parts and some wooden piece and some like this. You can see here some component. Here is some drawing are here which is I have drawn by this machine yesterday. So I'm going to final explain you about this machine, what exactly this machine, because I broadcast some videos, demonstration videos on TikTok and some my media. So some people are asking about the explanation of this machine. That's why today I am going to explain you almost things how this machine is work and what is the actually purpose of this machine. So watch the video until end, so you will get more information about this machine. So first of all, I will show you here the mechanism. This machine actually I developed for general purpose work here, like PCB develop and some another general drawing and 3D marking and 3D engraving. So this is tabletop machine. This machine size is 190 by 200 dimension. So this machine we can make the drawing or engraving sheet x-axis as a 190 and y-axis is the 200. So this table is my y-axis. You can see this table, and this the head. This head is this size. This is the axis, and here is a z-axis is here. I make just the clamp here by wooden general because I try to order this one by online and it's took long time to deliver me. Finally I make this by wood also, it's working, and I have a spindle motor. It's a 24 volt 6260 rpm with 24 volt, and once we give the 12 volt, of course it's a 50% less rpm is here. And I just clamp one pen here because this demonstration drawing I made by this pen here. I clamp here general pen here which is we are using for general purpose. And normally this is almost I made by this aluminum profile because I always make the machine by aluminum profile. Another everything is this the belt drive. Also I have two stepper motor, X and Y. This is X stepper motor and I have Y stepper motor here on the corner. You can see downside there, that side there is one motor, and this is the z-axis motor here which is driving by z-axis. So I will just show you now what is general work of this machine. And if I go to the software side, I'm using this general purpose grbl open source software, so I can control this machine very easily by through this USB port. I have this USB port connected here, and normal power is the 220 volt. 220 volt. I will show you the backside power and PCB after that. Finally I can make here manual data input here. This is a MDI command here. So once I type here, for the example I will type here z-axis is the display is really poor here with me. Example, I make the z-axis 0. So if I hit the enter, I can see I type here z-axis 0. This is the one. So I will make the enter here, and you can see the z-axis will be moved to the 0. It's moving now up to the 0. So this is the z-axis 0. I got it here. You can see normally, and I can make it again like z-axis here, whatever I like. Again I will type here z-axis 30 like this. So the machine will move again the z-axis 30. That's everything you can see here. And another I will this my machine is x-axis 190. It's a 200 by 200, but the x-axis there is little bit clearance is there, so 10 mm clearance is there. That is what I keep here for the safety. So I will just type this one here in the command x 190. So we can see it's move up to the 190 mm. So this is the maximum move here, 190. You can see here now it's moved to 190. As the same like y-axis, if I make the y-axis 200, so you can see the y-axis it's moved to the 200 also. So this is y-axis is moved to the 200 now. Finally, this is, you can see here some drawing yesterday night I make this one for my demonstration. This is something like the bed hood and the scene, and here is some picture are there what I drawn also by this machine, and some PCB drawing also I have here, which is I'm going to make some future project. So this everything is okay, and there is a tolerance is very low, like 0.1%, something like this. And the z-axis I have this ball screw type here. You can see here the ball screw driving, but the x and y is a belt drive, but even though it's working well. Now I am going to PCB side. What is the PCB develop here? You can see here one board which is I developed myself. This is motor driver breakout board, which is the stepper motor. 3 driver are here, this X, Y and Z, and plus I have some relay here. This is the spindle relay, and this is the coolant control relay. So another things I have here the microcontroller microprocessor board also. You can see here backside behind me where the USB is connected, and is blinking, means there is a data transferring there. And finally I have here 12-volt power supply. This power supply is general purpose 12-volt power supply, and I have given here 220-volt AC from the main supply. So this power supply will be given the 12-volt for this board, and this board will be drive that 12-volt to the stepper motor, all of 3 stepper motor plus spindle. So that's everything's backside. We can see here general, and I make one plastic cover to safety purpose here. This temporary also. I will make in the future something good box here, so I can control this everything's here. And I have still plan to add here one 24-volt power supply to control my spindle motor, because this my spindle motor is 24-volt. So I want to control this spindle motor separate by 24-volt and this another 12-volt. So this is my future plan. So I have something gap here. I can add one power supply, 24-volt power supply in the future. So you can see properly here by this the x-axis stepper motor. This is NEMA 17 stepper motor, also 1 ampere 12-volt 1 ampere DC stepper motor, and the belt drive is here. This is the pulley. So this all what I develop here, and I will show you here. This is the here is the y-axis motor is here. I tried to show before from another side here. This is the y-axis motor here, and belt drive is there also. And this is general purpose. This linear bearing guide is there. I made it by myself. Also here x-axis, you can see this is the x-axis linear bearing sliding guide. So that's all, everything is here. You can see this is the what I developed, this the PCB here from general board. Everything is here, we can see. And this is the power LED, which is you can see here the glow on, which is I connect the power, then it will be red. So still we have some another LED as far as the function. That's everything. So I can make here like a coolant control and a spindle. So there's you can see some light will be glow here. So you can see here one more LED is getting on and off. This is the like coolant control. I can make it the separately here the coolant float on and off. That's everything. So I will show you one drawing here live, so you can see how this machine will work, everything's. And this table, this is the table type of machine. You can see I keep on my table, so easily fit to the table, and we can do some job here. The tone is now on the software side. Now I have opened the software here. This is grbl open source software. So I'm going to open some drawing here, which is I drawn here in the sketch of 3D to 2D. So finally I have here so many drawing here, so just as I make it this drawing, I will going to open here. You can see the some G code are open here, which is I am going to draw on here is, and the visualizer is here. This is Durgama picture is here, so I am going to draw this one here on my table. On the table side, now I am here. I set some, I have here a small space here. I'm going to try manage here this draw. If I see here this the drawing dimension, you can see here this is a 50 by 46 and 5 milli height clearance is there. So as far as that, I have to set my table dimension here. Let's reset the dimension here. So finally I have to connect my machine here to the USB port. So this once I click here, we can see some connection is going on here and some data are reading here. Retrieve some data from the my microcontroller and it's sending some data also here. So in this case, just I'm going to set my machine here 0. I have to set move the machine to the 0 point here. I have option here to set the 0. So when I click here, you can see my machine is going to set the 0 here. So in this case, this is my machine 0, but I have to move manually to up to my destination here. So I will make the y minus here this much, and I have to go to the also set here y minus up to this corner here. Finally my destination is reached here on the 0. So this is y0 where I want to set the drawing from here, and it's a x minus. I'll do also here. This is the x minus approximately, let's say. So the x is approach here. This is what I want to make x axis, and still I have y set here. So this is my maximum y0. So I'm going to set the z axis also here. So as far as the z is little dimension is wrong here. I will set the x plus more here 2 milli, that's all. So z axis, I hope this will be work here. So this is my 0 set here. Finally I have to make here x, y and z, the manual 0 here, the some dimension is here in the DRO. So I make this one 0 x, y and z here. So once I press the move to 0, so my machine will be move here. Finally this is the 0. So let's start to draw on the drawing here by clicking the play button. So we can see here now he is start to draw some drawing here. This is what I am going to draw here. You can see here how the dimension, how is the 3D visualizer is showing here the as far as the drawing, and this the position movement is here. Finally the drawing is start to drawn here. Just I will show you by the little clear near to by my tally option here. So you can see some, its the dimension is approximately 40 by 50 dimension. So I hope this place will be enough to draw.